Five continents coming together. Learn and explore with Anil Kumar. Here is Matasabia, a student from Ethiopia. He wants to learn trigonometric identities and equations. I'm going to share with him questions which have been shared by Amy, a student of mine in Europe. Here in North America, I'll be connecting those questions from Europe to a student in Africa. That's the beauty of learning. Our approach, engaging minds, help us to connect the concepts learned to apply in different places depending on the context. We will see how these questions in England can help a student in Ethiopia. Matasabia is a grade 11 student. He has keen interest in mathematics, and I'm sure with his passion of learning, he is going to go way ahead. We'll also learn about some wildlife in Ethiopia in this particular video. I hope all this comes together. Enjoy our lesson with Matasabia, questions from Amy, and explanation which will hopefully help all of you. You can join my classes by sending an email on the address given. Share the passion of learning. Ignite the spark of knowledge. Let's enjoy the lesson with Matasabia. Hi, Matasabia. How are you doing?
Doing great, sir. How are you?
Very good. Very good. So, today, what do you want to learn?
In today's class, I want to learn about the compoundable formula and how we can derive formulas.
Very good. I will share with you some questions from my student Amy, who is in England. So we will see how you are in Africa, and from Europe we will pick up the questions, and I am sitting here in America, connecting all the things together. That'd be wonderful, correct? But before we get into that, we would like to know something about you. Can you please tell us who you are, from where you come, and I would like you to share something from your country.
Okay. My name is Matasabia, and I'm from Ethiopia, which is located in Africa, and I'm grade 11 student. And in our country, Ethiopia, there are a lot of tourist sites, and as you know, our country is our world hottest place is located also in Ethiopia, which is Dalol. And I can share you some endemic mammals from Ethiopia.
Sure.
Yeah, I'll share the.
Share one of the animals.
And the wolves are very sociable mammals.
Yes.
As you look in the screen, they are very sociable and they are very fascinating. I love so much them.
Correct. Wonderful picture. So from whichever resource you have used these pictures, they are very good pictures, good selection. That's nice to see.
It's also very interesting. As you look here, his legs are inside, I think, in the hole.
Yeah.
I love it.
Yes, probably trying to catch some animal out there, right? Or feeling. Must have been chasing some rabbit or something, correct? Good. So, with this introduction to endemic species in Ethiopia, let's begin with our lesson on trigonometry, correct? So, as you wanted to learn, we'll look into the trigonometry part now. So, let me share with you today's questions, which I thought I will share with you. Now, these questions are very interesting. Can you see my screen?
Yes.
Now, I will share 4 questions with you, which earlier I had discussed with my student Amy in UK.
Yeah,
So
sir.
because you follow the same curriculum at Excel
Yeah, but
curriculum,
yeah,
international
sir.
GCSE.
By the way, sir, I want to tell my appreciation to student Amy and I appreciate her a lot. Helpful for her.
Yes. So here we'll look into a few questions. Like one of them is question number 1, which says, show that 2 tan x minus cot x equals to 5 cosecant x may be written in the form a cos square x plus b cos x plus c equals to 0, stating the values of the constants a, b, and c. So first part is we have to rewrite the given equation, which is 2 tan x minus cot x equals to 5 cosecant x in cosine terms. Do you see? All are cosine terms, and it is a quadratic
Yeah,
equation. Now, this itself is a very important strategy, right? So, this is a strategy. What I love about Edexcel question papers is they help you understand the concept better while they are testing you out, even in examination, right? So they gave you an
okay.
equation which is 2 tan x minus cot x equals to 5 cosecant x. And now they're saying this equation can be written in terms of cosine as a cos square x plus b cos x plus c equals to 0. Now, stating the values of constant a, b, and c, we need to find these values, correct?
Yeah,
Now, based on this, they have a very similar question, which is hence solve where x is between 0 to 2 pi, 2 tan x minus cotangent equals to 5 cosecant x. Now, normally they use the same values. However, this time they put minus cotangent x. Maybe the value of b is negative in the first case, right? Maybe.
yeah,
So let us begin with the first question, part A, and then we'll come to part B. Is that clear to you? Okay.
yeah.
Now, can you tell me how will you prove this identity or rearrange the equation? So we have what? We have 2 tan x minus cot x equals to 5 cosecant x, right? And we have to write in terms of cos. So how will you tell me how will you do it?
I think we have to change tonics into code, the both
Sine
code
and
in the
cos. Better to write sine x and cos x. Do you understand?
yeah, yeah,
Because finally we want in terms of cos x. So do not go into cotangent, right? So write in everything in terms of sine and cos. Is that clear to you?
yeah,
So what is cosecant x? 1 over sine x. So we have now written this equation, and next step should be what for you? Tell me.
1/6.
So what we can do now to simplify is we can multiply both sides by the common denominator,
Tonics.
which is cos
Yeah,
x sin x. Do you see that?
yeah. The
So we
simple.
multiply by common denominator and then we expand. So the first term, cos x will cancel. And what do we get?
Two
We get
sin square x.
sine square x
Yeah,
minus, here sin x
minus
cancel, we get cos square x,
what
right?
cos square x. Yes,
Equals to 5 cos x. Is it clear to
cos
you?
5x. Yeah,
Now,
cos
we do
x.
not want sine. We will convert this sine into cosine. How? We'll write this as 1 minus cos square x, correct?
Yeah,
And now we can expand 2 minus 2 cos square x minus cos square x equals to 5 cos x, correct? Bring all the
yeah,
terms together. So I'll prefer to bring them to the right hand side, making cos square x is positive. So it is 3 cos square x plus 5 cos x minus 2 equals to 0. Is that clear to you?
yeah,
So that is what we get. And clearly from here, if we compare A, B, and C, then A is equals to 3, B is equals to 5, and C equals to minus 2,
minus
correct?
2. Yeah,
So that is how we are going to solve that particular question. Is that clear to you?
yes.
So that is one part done. Now in the second part, we are not able to use this equation because they have put minus cotangent x in between, right?
Yeah.
So we'll have to redo all this. But now you understand the concept, correct?
Yeah.
So, so we will erase this for now, and then we'll work into the second part. Is it okay?
Yeah.
Okay, let me just delete this. Oops, everything went. Wait. We don't want that to go. Okay, so in that case, what to do now? Let me erase with this eraser. So, Matasabia, can you do part B?
Yeah.
Yeah, try to get the equation in cosine and then we'll solve it. Is it okay?
Okay.
So now we are working in part B. So let me also do and you also do your work. So 2 tan x minus cot x equals to 5 cosecant x. We'll follow the same process, which means we'll write tan in sine and cosine, right? So let me
Yeah.
take it up and we'll write like this. So we have 2 tan x minus cot x equals to 5 cosecant x, right?
Yeah.
We'll write this as 2 sine x over cos x minus cos x over sin x equals to 5 over sin x. Multiplying by sin x cosine x as we did earlier.
Yeah.
So this is a very important step. It removes denominator, right? So it becomes
Yes.
easier for us to simplify, right? Okay, so 2 sine square x will be 1 minus cos square x. So open the bracket, 2 minus 2 cos square x minus cos square x equals to 5 cos x. Now we will add these two terms. We get 2 minus 3 cos square x equals to 5 cos x. Bring them together.
Equals
Plus 5 cos x
minus
equals to 0, right? So that is the equation which we need to solve. So how will you solve this equation? Tell me.
in the value of mm,
We'll look for product and sum, right? So we need a product of minus 6. So two numbers when multiplied should give us minus 6 and we want to add them to plus 5, correct?
yeah,
So the two numbers could be what?
minus 3 minus 2.
So we need 6 and 1, right?
Oh, yeah.
Correct? And positive
Yeah.
6 and minus 1 will work for us. So using this, we can rewrite this as 3 cos square x plus 5s plus 6 cos x minus cos x minus 2 equals to 0. 3 cos x is common. So we're left with cos x plus 2
Plus 2
minus, we have cos x plus 2 equals to 0. So now cos x plus 2 is common, right? And so we
yeah,
get 3 cos x.
x minus
Very good question. Do you see that? Very beautifully designed question. It is not a straightforward question. You have to apply many concepts learned. And now, when you have cos x equals to 2, so which is not possible, right? So that is no solution, correct? Because the value of cos x is between plus minus 1. But in this case, we have cos x equals to 1 over 3, correct? So we
yeah.
have a solution here. So within 0 to 2 pi, we can now find the solution. We want 1 over 3. So can you tell me what is the solution for this?
Okay.
Find the related acute angle alpha. So we know alpha equals to cos inverse of 1 over 3, right? Use your calculator in radians, find the answer. We get 1.23, right? So 1.23, and the other angle will be what? 2 pi minus 1.23, right? So x will be equals to 1.23, the acute angle, and then we have 2 pi minus 1.23. You understand why? 5.05. Did you see that? So you have to
Yes.
always find related acute angle and then the other angle, right? So we are working in the domain where the value of x is between 0 to 2 pi radians. Is that okay?
Yeah.
Do you understand all the steps involved in this?
Yeah.
Perfect. So that is how we could do this particular question. And next question is again tan theta plus cot theta equals to lambda times cosecant 2 theta. I'd like you to copy this question and try it out. You have to find the value of lambda in this case. Okay. So that is
Yeah.
your homework. Perfect. Let's move on and take up the next question.
Mm.
Question number 2. Question number 2 is express 4 cosecant squared 2 theta minus cosecant squared theta in terms of sine theta and cos theta, right?
Mm.
Hence show that 4 cosecant squared 2 theta minus cosecant squared theta equals to secant squared theta. Hence or otherwise solve for theta being 0 to pi. 4 cosecant squared 2 theta minus cosecant squared theta equals to 4, right? You get the question right. So first,
Yeah.
we have to begin with the expression and we have to write it in terms of both sine and cosine, correct? Once you
Mm.
do that, so you could actually also show that this is equal to secant square theta. That's an exercise. And based on this, we have a question here that all this is equal to 4. So when you look at these two questions, right, you can correlate one thing. 4 cosecant square 2 theta minus cos square theta is secant square theta, which is equal to 4. So one part of the equation becomes simple, which is secant square theta equals to 4 needs to be solved. Do you see that?
Yeah.
So you can actually easily do part C even without doing part A and B. You get the idea.
Yeah.
In the examination, suppose by any chance you have less time or you are unable to prove part A or B, but still you can do part C, correct?
Yeah.
Because that gives you that left side is secant square theta, and here the left side is equals to 4. So that means secant square theta equals to 4 can be solved. That is simple, right? So let's
Yeah.
begin with the last part where we need to solve for theta. Secant square theta equals to 4 means secant theta is equal to what? Plus minus square root of 4, which is plus minus 2. Is that clear to you?
Yeah.
So when secant theta is plus minus 2, that means what? It means cos theta is equals to plus minus half, right? And that we
Yeah.
know from a special triangle which angle we are talking about. Can you tell me what is the answer?
And the first in the fourth quadrant.
Yes, first and fourth quadrant, right? So let me draw the quadrant also. And we're saying
5 over
first
6.
and the fourth, and the acute angle is pi by 3 from the triangle, special triangle, right?
Yeah.
So we have to only give an answer which is between 0 to pi, and therefore theta is equals to pi by 3. Is it okay?
Yeah.
So we have done part C. without even doing part A and B. That's not a bad idea, right?
Yeah.
Now we will do part A and B. This is also a strategy to solve questions. Sometimes students can get some difficulty in doing part A and B. They can actually jump to part C and solve it as we have done just now. Is that clear to you, Matasabia?
Yes.
You
Correct.
like this strategy?
Yeah.
Let me erase this and we'll do part A and B now. Is that okay?
Yeah.
Correct. So tell me what should be your approach to do part A, which is we have 4 cosecant square 2 theta minus cosecant square theta. We have to write this in terms of sine and cosine. So what should I do? So what is
Secant
cosecant square?
1 over sine theta. 4 into 1 over.
Sine square 2 theta, correct? Minus
Yeah.
1 over,
Sine.
correct. So what is sine 2 theta equals to? You remember? 2 sine theta cos theta is the value of sine 2 theta and we'll square it, correct?
Yeah.
Correct. And how will you write 1 over sine square theta? Tell me. Well, we can leave it as such because you want both sine and cosine terms, right? So let's open this bracket. So let's just keep it as 1 over sine square theta for now, right? And here, what do we have? We have 4 over 4 sine square theta cos square theta, right? Minus 1 over sine square theta, correct?
Yeah.
And now 4 and 4 cancel. And so what do we have? In the denominator, we have sine square theta cos square theta as common, right?
Yeah.
So I'll write this as sine square theta cos square theta. And in the numerator, here I'll get
1.
just 1, right? And here
1
I'll get
minus.
1 minus cos square theta, correct?
Yeah.
So that is an expression which involves both sine and cosine, right?
Yeah.
The question also says one thing. So we have done this part, which is writing in terms of sine and cosine. Now part B is we have to further simplify this and write down the right hand side as secant square theta, correct?
Yeah.
So let us extend this and do part B to write down as secant square theta. So we have 1 minus cos square theta over this, correct? So we can write this as equal to what? What is 1 minus cos square theta?
Sine square theta.
And denominator is sine square theta cos square theta, correct? So
1
sine
over.
square theta cancels
1
and
over.
we are left with what? 1 over cos square theta, which is secant square theta. Do you see that? How we are going to
Yes.
do it? And we have
Yes.
already done part C, that is secant square theta is equals to 4, and we completed the question. Is that clear to you? Correct? So that is how
Yeah.
we could solve this question. Let me take another question, right? So the video will be shared, and therefore you can go through it later also, right? So I'm going slightly faster. I want to cover up these questions today. Now, question number 3. Prove that 1 over sine 2 theta minus cos 2 theta over sine 2 theta equals to tan theta. Right. So first do this. Identity. How will you do it? Tell me. You know the formula? What is sine 2 theta formula?
And
And what is cos 2 theta formula? Cos 2 theta has 3 formulas, which is cos square theta minus sine square theta. Also 2 cos square theta minus 1 or 1 minus 2 sine square theta, correct? So these are the 3 formulas which could be used for cosine. Now, when you to solve this identity, let's see how. So 1 over 2 sine theta, sine 2 theta could be written as 2 sine theta cos theta, correct?
yeah.
Minus. Now we have a choice. Cos 2 theta can be written as one of these, right? Correct. We could also think about the right hand side to be tan 2 theta, right? And we can expand it in tan 2 theta. That also we could do. But we will maintain cos and sine terms. Is that okay? Correct?
Yeah.
Okay. So, uh, but you have a choice. You could write this as tan 2 theta also. Is that clear to you? So, what will you
Yeah.
put? We want to show that this is equals to tan theta. So directly, because we have a term sine 2 theta, so what we can do here is we can also write sine 2 theta as a common denominator, right? Because we have cos 2 theta in the numerator, right? You see this is a common denominator, right?
Yeah.
So we'll write this as 1 minus cos 2 theta for now. Denominator being 2 sine theta cos theta. Is that clear to you?
Yes.
Now if you look at it, cos 2 theta can be written in three different ways. It is 1 minus cos 2 theta. So 1 minus cos 2 theta means I should be in a position to cancel 1. So which formula should I use? I think
The
1,
formula 2 cos square theta.
that is better, right? So I'll write this as denominator being 2 sine theta cos theta, numerator being 1 minus. So instead of cos 2 theta, I'll write as 1 minus 2 sine square theta. Do you see that?
Yeah.
Now, as you can see, 1 and 1 will cancel. Do you see that? 1 minus 1.
Yes.
And
Yeah.
what do we get? We get 2 sine square theta,
Over and theta.
2 sine theta cos theta. Now that helps you. Do you see that? 1
Yeah.
sine theta cancels, 2 cancels, and we are left with sine theta over cos theta. Do you see this?
Yeah. 1 over left.
So which
Yeah.
is right hand side? Is it okay?
Yeah.
So do you notice what I did was I did not write cos 2 theta, sine 2 theta in terms of cotangent or tangent 2 theta, correct? We took the advantage of common denominator, simplified the numerator, and strategically we have used cos 2 theta as 1 minus 2 sine square theta so that they cancel at this stage. You get the idea.
Yeah.
So that is the simplest solution to the given question. Is that clear to you?
Yes.
Perfect. So we have done this part. Is it clear to you, right? I can erase this now.
Yeah.
Correct. Let's do question number 2, which is solving an equation with double angle, correct?
Yeah.
Rather finding the exact value. So question number 2 is, hence or otherwise, show that tan 15 degrees is equals to 2 minus square root 3. How will you do it?
I think we have
You
to
can
use
use
half
this
angle.
relation. You can use this relation, right? So tan theta is what? 1 over sine 2 theta, correct?
Yeah.
So we can say that tan of 15 degrees will be what? 1 over sine of 2 times 15 is 30, right?
Yes.
Minus cos of 30 degrees over sine of 30 degrees. Do you see that? It becomes much more simpler, correct? And
Yeah.
sine and cosine values you can take from the special triangle, correct?
Yeah.
Right. So we have 1 over sine theta. Sine theta value is what? Sine 30 degrees
1
is
over.
half. So it will be 2, right? Minus cos theta over sine theta, which is cotangent theta, right?
Yeah.
For 30 degrees. So it will be square root 3, right? We get our answer. Does it make sense? If you want,
Yes.
you could write like this 1 over half minus cos of 30 is what? Square root 3 over 2. Sine of
Over.
30 is 1 over 2, correct? And then you can go to this step. Is that clear to you? So
Yeah.
once you have done part A, you should actually use that result to find the exact value for tan 15 degrees as shown in these calculations. You get the idea.
Yeah.
Perfect. Now, So we've done part A. Let's do the next question, which is solve for x being 0 to 360 degrees for cosecant 4x minus cot 4x equals to 1. This solution we need, right? Can you solve this? 5 marks.
Mm.
Let's do it. So these are the questions which Amy has shared with me while she's preparing for Edexcel level A. So we have this equation which is cosecant 4x minus cot 4x equals to 1. Cosecant is 1 over sine 4x minus cos 4x over sine 4x
Yeah.
1, right? So sine 4x is common. We can write 1 minus cos 4x equals
Over.
to sine 4x, right?
Yeah.
So now we have cos 4x and sine 4x. How are we going to solve this equation? Yes.
We have to. We have to collect like them as a render. We will square both sides.
Correct. So we have cos 2x formula, right? Which is 1
Yeah.
minus 2 sine square x, correct?
Yeah.
So cos 4x will be what? Cos 4x will be 1 minus 2 sine square 2x, correct? So we'll
Yeah.
replace this with 1 minus within bracket 1 minus 2 sine square 2x. Is that clear to you? Which is 4x,
Yeah.
right?
Yeah.
Sine square 2x, sorry, sine square 2x, correct? And
Yeah.
sine 4x will be written as 2 sine x, sine 2x. Let me rewrite this, okay? So 1 minus cos 4x can be written as 1 minus 2 sine square 2x. And cos 4x will be written as 2 sine 2x cos 2x. Is this clear to you?
Yeah.
Now 1 and minus 1 cancel. We'll open the bracket. And what we get is 2 sine square 2x. And on the other side, we'll bring them here. 2 sine 2x cos 2x equals to 0. Okay? You
Yeah.
cannot take sine 2x common. 2 sine 2x common. And you have sine x, sine 2x, sorry, cos 2x minus cos 2x equals to 0. And that means these factors being 0, right? So that gives you an example here, which says what? We have 2 sine 2x equals to 0. And here we are saying sine 2x minus cos 2x equals to 0, right? We need to solve this now. Let's take it up. So let's solve this. So let me bring it here. We have to solve two equations. One is 2 sine 2x equals to 0. The other one is sine 2x minus cos 2x equals to 0, right?
Yeah.
Now this is simple. When is it 0? Well, you can actually graph and you know exactly when you graph when sine 2x is 0, right? Now, what was the domain? We have to find between 0 to 360 degrees. So we have to find between 0 to, is 0 included? So this is very critical. Do you see this?
Yeah.
0 and 360 degree is not included in the domain. Do you see that? You have to be very careful, particular, right? And therefore, we cannot give the solution which includes 0 and 360 degrees. You understand?
Yeah.
Okay. Now, for sine, we have for x 0 to 360 degrees. So for 2x, this domain will be from 0 to 720 degrees, correct?
Yeah.
So as far as 2x is concerned, we have the value of 2x equals to 0, right? Sine 2x equals to 0 will give you what values? 0, 180, like this, all the values, right?
Yeah.
0, 180, 360 to keep on adding 180 to this, correct?
Yeah.
So when you add 180, so we get what? 540 and 180. So we have 5 values, right? 720, right? So x is equal to half of this, which is 0, 90 degrees, half is 180 degrees, half is 270 degrees, and half is 360 degrees, correct?
Yeah.
However, in the domain, we are not including 0 and 360, so they will not be reported, correct? You get
Yeah.
the idea? Very important part. So from here, you're only including 90 degrees, 180 degrees, and 270 degrees. Now let's look into the second equation, which is sine 2x minus cos 2x equals to 0. How will you solve this? We have sine 2x equals to cos 2x divided by cos 2x. So we have tan 2x equals to 1. And tan 2x is 1 when? It is 1 in quadrant 1 and 3, right?
Yeah.
For 45 degrees acute angle, correct? So we can have 2x equals to 45 degrees and keep on adding 180 to this, right?
Yeah.
135. And then again you get back 360 plus 45, right? Which is 405. And then add 180 again, 585. And now x is half of these, 22.5, and keep on doing half of these values, right? 292.5 is last. 2 times 6, 7. Do you see that?
Yeah.
So for this, we get these 3 plus these 4 as our solutions. Does it make sense to you? So do you see how in different parts of the world, we are using the same formula and, approaching to different solutions, different kind of questions are being attempted. So Edexcel follows a system where we have different parts in equations, right? We derive one result, another result, and then find the values from the third one. So they are interrelated questions, and it's very interesting. It's also a learning exercise for students. Okay.
Yeah.
Let us now take the last question of this day, of this class. We need to prove sine 2x minus tan x equals to tan x cos 2x, where x is not equal to 2n plus 1 times 90 degrees. Given that x is not equal to 90 and 270, solve this equation, which is sine 2x minus tan x equals to 3 tan x cos sine x. Is that okay?
Yeah.
So let's begin with the very first one, prove the identity. Can you help me prove this identity? Sine 2x minus tan x equals to tan x cos 2x. So from which side will you like to start?
From left hand side.
Okay, let's start with left hand side. So sine 2x can be written as sine 2 sine x cos x, and tan x can be written as sine x over cos x, correct?
Yeah.
So this is equal to, let's take a common denominator of cos x. We get 2 sine x cos square x minus sine x. Is it okay?
Yeah.
Now you can take sine x common. So you're left with 2 cos square x minus 1 over cos x, correct? So clearly you see two parts. One is tan x, the other one is cos 2x, correct?
Yeah.
So let me rewrite this sin x over cos x times 2 cos square x minus 1, which is tan x times cos 2x. Do you see that? Which is
Yes.
right hand side. Is that clear to you? So that is
Yeah.
how we could easily solve this particular question. It's kind of tricky, because you see, this is the most, I think, the simplest way of solving. So have a good look at it. Okay. Now, based on this, we have a question, which is this time sine 2x equals to 3 times, not 1. Do you see, this is 3 times tan x sin x. Is that okay?
Yeah.
So the left hand side they have made equals to 3 times tan x sin x. Earlier we showed that this is that equation, right? It says give your answer to degrees to one decimal place where appropriate within 0 to 360 degrees. How will you solve this question? You can write the left hand side as tan x cos 2x, correct?
Mhm.
So let's do that part now. You see how one question helps you to solve the other one? And that also gives you an idea. If you cannot solve the first question, you can always uh, look into its solution and use the result, right? So what we are going to do here is relate the two things, right? So what do you see from here? So we see that sine 2x minus tan x is equals to what? Is equal to tan x cos 2x. And now they are saying it is equal to 3 tan
Yeah.
x sin x. Do you see that?
Yeah.
So we can bring them together and then answer, right? So we get 0 equals to 3 tan x sin x minus tan x
Thanks.
cos 2x, correct? So
Yeah.
we can take tan x common, 3 sin x minus
Minus
cos
one.
2x. We are working within 0 to 360. 0 is included in the solution. Do you note this? 0 is included, 360 is not included. So we
Yeah.
have one solution for tan x equals to 0. And clearly, 0 is one of our solutions, right? Tan x 0. So 0 degrees is x equals to 0 is one of our solutions, correct?
Yeah.
The other solution being what? 180, correct? So, correct? So tan will be 0 and 180 degrees will give you two solutions. And now we have this other part to do, which is 3 sin x minus cos 2x, correct? So this part, how will you do? So you have 3 sin x minus cos 2x. Cos 2x now should be written as 1 minus 2 sine square x, correct? So now you solve this equation. Is it okay? So we have 2 sine square x minus 3 sine x minus 1 equals to 0. So you can factor this. We are looking for a product of minus 2, sum of minus 3. So 2 times 1 works for us, right? So we get 2 sine square x minus 2 sine x minus sin x minus 1 equals to 0, right? So
Yeah.
that gives you 2 sin x common. And here we have sin x. That minus and minus becomes, should become plus.
Signing.
Okay, plus and minus becomes plus. Minus, no, this was minus only. Wait, we have minus and minus. So minus and minus. So we have 2 sin x minus 1. And if I take sin x, 1 minus 2 sine square x. So when I open the bracket, 3 sine x. Oh, it was 2 sine square x. I did a small mistake here. So let me redo this. Is it clear to you?
Yeah.
So when I open, I got 2 sine square x. 2 sine square x. And then we have plus 3 sine x. And here we have minus 1 equals to 0. Correct? So now
Yeah.
let's do product and sum. So we need minus 2 and we need minus 2 and plus 2. So how will you do? 1 minus 2 sine square x and then plus 1 and this is plus 2. Okay. So we need a product of minus, minus 2 and sum of plus 3. So it cannot be factored directly. Is that okay? So we have to use quadratic
Oh,
formula.
yeah.
So quadratic formula is what? Sin x equals to minus b, which is minus 3, plus minus b squared, which is 9, minus 4ac. It becomes plus 4 times divide by twice a, 2 times 2, right? So we get this as minus 3 plus minus square root of 8 plus 9, 17 over 4, correct? So we have this value. So you can now calculate what is square root of 17. Square 4.123, right? So we have minus 3 plus minus 4.123 over 4, correct?
Yeah.
So that gives you two solutions, minus minus. So this plus 3 equals 2 divided by 4. So one value is minus 1.78, which is not valid. The other value will be 4.123 minus 3 equals to divided by 4 equals to, in decimals, it is 0.28. Is it okay? So we have two solutions here. 0.28 is valid, and we'll find sine inverse, right? So we have what? Let me rewrite. Sine x equals to 0.28. So x is sine inverse of 0.28. So let me convert this to degrees now. And then we'll do sine inverse 0.28. And we get 16 degrees.
Yeah.
Correct? So
Yeah.
we have to write the answer to one decimal place. So 16.3. And the domain is up to 360, right? So this is positive in quadrant 1 and in quadrant 3, right? So we know this angle, which is 16.3. So the other angle is how much? 180 minus 16.3, right? So x equals to 16.3 degrees and 180 minus 16.3 degrees. So minus 180. 163.7. So 16.3 and 163.7 degrees. Do you see that? So we get these two solutions, and already we had these. So x is equal to this, and also 0 degrees and 180 degrees, correct? So that is how you could find the solution of this particular question, correct? Did you understand all this?
Yeah.
So we did it kind of fast, but you should not take your time to answer these questions at your pace. Try to understand what we did, right? So I hope that is going to help you, correct?
Yeah. Yeah.
Any doubts? Any doubts? Matasabia, any doubts?
More in the different reference.
Okay, so we'll stop the screen now. Can you tell me what did you learn in today's class, Matasabia?
In today's class, we are learning about different states problems, which is shared from and we had a good time, and I love the.
Good. And I also like the selection of the wild wolf. That was nice to see with the pups especially. Okay, great. Have a great day. Try some questions from my YouTube channel. And if you have any difficulties, feel free to share them. Okay? Thank you. And
Okay.
all the best.
Thank,
Bye.
thanks. I love you so much.
Same here.